So topic 7-2, more similar polygons. Um, so recall the definition of a polygon as polygons with the same shape but different sizes. Okay, so same shape, different sizes. And remember, how do we get the same shape? Well, the corresponding angles have to be congruent. And how do we get different sizes? Well, the corresponding sides have to be proportional. So those are the two things we're looking for. Okay, corresponding angles. I'm going to abbreviate. So corresponding angles congruent. And then number two, corresponding sides are proportional. Okay, all right, so the first thing I want to do is I want to check to see if the corresponding angles are congruent. Well, so when I look at these two triangles, and the first thing I notice here is I have a right angle here, okay, and I have a right angle here, so that's all good. But the problem is I don't know what this angle is, and I don't know what this angle is, but I know that a triangle has 180 degrees, so I can kind of figure this out. I'm going to kind of take the easy route. I know that this angle and this angle, they're the acute angles of a right triangle, so I know they have to add, they're complementary, means they have to add up to 90. And so I'm just going to say, okay, 90 minus 37 is 53, and so this angle is 53. And so now when I compare the angles of these two triangles, I got a right angle, I got 53 degrees, I got a right angle, I got 53 degrees. Here I have 37, so that means that this angle has to be 37, which means that we've kind of cleared checkpoint 1, the corresponding angles are congruent. All right, so now I need to clear checkpoint 2. Well, checkpoint 2 is the corresponding sides are proportional. So 9 corresponds to 6, 3 corresponds to 2, and 18 will correspond to 12. And it doesn't matter which order you write these in. So I'm going to go big to little, but it doesn't matter. You can do little to big. But the thing is I want to make sure that I stay consistent. So if I do the big triangle on top, I want to make sure I do that all the way across. 9 over 6, 3 over 2, and 18 over 12. And all of these fractions will simplify to 3 halves. So 3 halves, this one's already simplified. 18 over 12 simplifies to 3 halves. So that's good. And so check number 2 also checks out. So the corresponding angles are congruent and the corresponding sides are proportional. And so the two figures are similar because of those two things. The corresponding, this time I'm going to write it out, the corresponding angles are congruent and the corresponding sides are proportional. Okay. So when we're checking for similarity, those are the two things that we're checking for. So in example number 4, now this time I am told that these two quadrilaterals are similar to each other. That's what this little mark means. It means similar. And so if they're similar, then I know that the corresponding angles are congruent and the corresponding sides are proportional. And so I'm going to start with the angles. So A corresponds to E. So that means that E is 60 degrees. F corresponds to B. So that means that B is 100 degrees. And H and D will also be congruent. And so what I need to think about here is this. I know that a quadrilateral has 360 degrees. Kind of one way for you to determine that is if we draw a diagonal here. So now I created two triangles, and each one of these triangles have 180 degrees. And so because of that, the total sum of the interior angles is 360 degrees. And so if I want to find angle H or angle D, it doesn't matter. So I'm going to say 90. Well, I'll start with the big number. 100 plus 90 plus 60 is going to give me 250 degrees. And so to find the remaining angle, I'm just going to say 360 minus 250. And I know that's 110 degrees. And so angle H is 110. And angle D is also 110 degrees. And so now we can answer these questions. So angle E is 60. Angle G, well, that was easy. That's 90. Angle B is 100. And angle H is 110. Okay, so for part B, it says, what is the common ratio of ABCD to EFGH? All right, so AD will correspond to EH. AB will correspond to, sorry, AB will correspond to EF, and BC will correspond to FG, and DC will correspond to HG. And so when I look at this, I only know, well, I know that DC is 6, and I know that HG is 18, okay? And so the common ratio of ABCD to EFGH will be 6 over 18, which is 1/3. And so the common ratio is 1/3. Now, if I switch it around and I say quadrilateral EFGH to quadrilateral ABCD, then it would be 3 over 1 or 3. Okay, so now I want to find the following. I want to find EH, okay? And I'm just going to kind of do this in my head, okay? And I'll show you how I'm going to do this. So if I compare 6 to 18, there's two things that I can say here. I can say that 6 is 1/3 of 18, or I can say that 18 is 3 times 6. Okay? And so either thing that you say there is correct. And so if I want to find EH, well, I know that EH is going to be 3 times AD, and so EH will just be 15. And so you might be saying, well, how did you get that? Well, it's pretty simple. 3 times 5. Okay? 3 times 5 is 15. If you want to set up a proportion, 6 over 18 equals 5 over x. 6x equals 90. X equals 15. Okay? Divide both sides by 6. And sorry, I'm kind of getting ahead of myself. And so x equals 15. Okay? So we're just using the fact that those sides are proportional. Now, if I want to find BC, well, this time I'm going the other way. I know that BC is 1/3 of 9, just like we said 6 is 1/3 of 18. Well, what number is 1/3 of 9? Well, that's easy. 1/3 times 9, I'll do this one in red. So 1/3 times 9 is just 3. Now, here again, if you want to set up a proportion, 6 over 18 equals x over 9. Cross multiply. 18x equals 54. Divide both sides by 18. 54 divided by 18. X equals 3. Okay? And so for the last segment, if I want to find AB, well, here again, I know that AB is 1/3 of EF, so 1/3 of 21, I'll use green for this one. So 1/3 of 21 is going to be 7. And so that's all I have to ask myself. What number is 1/3 of 21? And so 1/3 times 21 equals 7. Now, if I want to set up a proportion, 6 over 18 equals x over 21. And so 18x equals 1/26. Divide both sides by 18. 126 divided by 18, x equals 7. Okay? But here again, all we're doing is we're using the fact that the corresponding sides are proportional and the corresponding angles are congruent. Okay? So in example number 5, it says the lengths of the sides of a triangle are in the ratio of 3 to 5 to 7. Its perimeter is 120. Find the length of the shortest side of the triangle. So the easiest way for me to explain this problem for you is to, let's just say this. We're going to say that x equals the common ratio. X equals the common ratio of the sides. Okay? And so when we set this up, we're just going to say 3x plus 5x plus 7x equals 120. How do we find perimeter? We add up all the sides. So 3x and 5x is 8x plus 7x is 15x equals 120. We're going to divide both sides by 15. And so the value of x, the common ratio, is actually going to be 8 here. So the common ratio is 8, but notice what they tell me to find. Okay, find the length of the shortest side of the triangle. Well, the shortest side of the triangle is going to be the smallest number multiplied by the common ratio. And so the shortest side here is just equal to 3 times 8, which is equal to 24. And that's what we're after there. Okay. All right, so in example 6 is going to be very similar to example number 5. It says the measures of the angles of a triangle are in the ratios 1 to 2 to 3. Find the measure of the largest angle. And so this time, we're going to say x equals the common ratio of the angles. Okay, so the common ratio of the angles. So there's some number, x, that I can multiply each one of these numbers by that's going to add up to 180. And you might be saying, well, where did you get 180 from? Well, remember, how many degrees does a triangle have? A triangle has 180 degrees. And so here's what we know. We know that 1x plus 2x plus 3x is equal to 180. So 6x equals 180. We're going to divide both sides by 6, and the common ratio that we're looking for here is 30 degrees. Okay, and so here again, just like the previous problem, if we want to find the measure of the largest angle, well, this has to be my largest angle. So we're going to do 3 times the common ratio, 30 degrees, and we're going to get 90 degrees, and so the largest angle is 90 degrees.